Welcome aboard. Your learning journey starts now. Ever felt like the universe is hiding a secret? Four fundamental forces, each playing by its own rules. We've got gravity holding galaxies together, electromagnetism zapping atoms, and the strong and weak nuclear forces doing their quantum dance. Standard theories talk symmetry breaking, gauge fields, fancy math, but they often miss the why. What if the universe isn't just particles and energy, but a giant semantic system? Think DIKWP data, information, knowledge, wisdom, purpose. Could these forces be different expressions of semantic tension in this cosmic network? Let's dive in. So, what's this DIKWP thing? It's like a blueprint for understanding meaning itself. At the bottom, you have data raw facts, sensor readings, the universe's initial noise. Then comes information, recognizing differences, finding patterns, giving context. Think charge separation. Knowledge is where things get structured laws, constants, self-consistent systems like gravity. Wisdom involves global optimization, long-range connections like light-speed propagation. And finally, purpose intent, directionality, maybe even a cosmic tendency towards certain states. We model this using a semantic tensor field, essentially mapping physical events onto this 5D semantic space. It's not just a space-time, it's space-time plus meaning. Let's start with gravity, the big one, pulling everything together. In our semantic view, it's all about knowledge layer closure. Imagine information naturally wanting to form coherent structures, like knowledge itself. This drive for closure manifests as attraction. The semantic potential phi sub k of x essentially dictates the curvature R of spacetime. So, sub f is proportional to f of phi sub k. Why only attraction? Because semantic closure inherently pulls things together to form stable, meaningful wholes. It's the universe tidying up its information, ensuring related concepts cluster. Makes sense, right? It's the ultimate organizational principle. Next up, electromagnetism, the force behind chemistry, light, and everything, electric. Here, it's the dynamic duo of information and wisdom. The information layer perceives the difference, positive versus negative charge. But how does this difference interact across distances? Enter the wisdom layer, providing the long-range connection, the remote interaction capability. Think of the electromagnetic potential, a mu emerging from the coupling between the information field phi I and the wisdom field phi W, Maxwell's equations. They're just the rule book for how these semantic differences propagate and interact globally. It's got that cool duality too. Opposite charges attract, like complementary ideas, while similar charges repel, like clashing opinions. Nature's way of balancing attraction and repulsion. Now for the nuclear forces, the real heavy hitters at tiny scales. The strong force is all about local consistency, keeping quarks locked inside protons and neutrons. Think of it as the data layer demanding local uniformity or semantic coherence. The gradient of the data potential, nebula phi d, basically says, stay close, don't stray. This creates the incredibly strong binding. Then there's the weak force, responsible for radioactive decay. This feels more like the purpose layer, phi p, at work, driving transitions, changes in the semantic state, like particles decaying into more stable configurations. It's less about brute force, more about facilitating change according to some underlying purpose or trend. And remember, these layers didn't always operate independently. The universe evolved from a high semantic symmetry, gradually decoupling these layers, leading to the distinct forces we see today. So, wrapping this up, this DIKWP framework offers a unified lens. Gravity, electromagnetism, strong, weak, all seen as different facets of a single semantic tensor field. What does this mean? It potentially opens doors to new ways of thinking about quantum gravity, dark matter, dark energy, maybe even those pesky observer effects in quantum mechanics. We can even propose experiments, look for tiny shifts in fundamental constants linked to these semantic layers, or use quantum information setups to probe these semantic factors directly. It's a bold idea, a meaning driven cosmos. Food for thought, wouldn't you say?